My name is Jodi and I teach into a range of subjects from biochemistry across to product design and chemistry, and I am a biochemist and I study proteins. The best thing about doing biochemistry is that biochemistry is amazing. Understanding biology at the molecular level is a real privilege. Like, this is one of my proteins that I study from bacteria that causes tuberculosis, and I can see at the level of atoms and molecules what's going on, and that's just an utterly amazing feeling. Every time I see something like this, even though I've done it for many years now, I still get really excited, and I feel it's an amazing privilege to be able to get that sort of insight into biology. So I think that you have curiosity and passion. This may not be your particular passion, but you find something and you can study and you can understand and you can ask questions, and then you can solve those problems and you can ask more questions, and I think that that's just amazing. I think that UC has a strength in that we teach biochemistry across two departments, biology and chemistry, so you really get an experience of how a chemist thinks about biochemistry and how a biologist thinks about biochemistry, and so you get enables students of different interests to come together and get a good background. At 100 level, or at 100, 200 and 300 level, you will be doing a mixture. So you'll be studying biology and chemistry, and also have the opportunity to pick up maybe some other electives that you're interested in, and you will be doing some lectures, tutorials, interactive learning and labs. So we teach practically from the stage 1 onwards, so you'll be doing labs, you'll be learning practical chemistry skills, practical analytical skills, practical biochemistry skills, practical biology skills. So you'll be having lectures mixed with labs basically from the beginning, and problem solving. So you'll be learning problem solving, practical skills, critical analysis, and a lot of subject specific material. Our biochemistry director developed this book that goes out to high schools called Interact, and it's just talking about some different pathways, and so some of the more common pathways. So we have the undergraduate degree program, and you can do biochemistry by itself, but you can combine it with medicinal chemistry, or you can combine it with sort of other biological subjects like molecular biology, microbiology, genetics. So those are two of the more common paths. Other people might want to combine it with other sorts of chemistry or other sorts of biology. I've had students that have combined it with, say, population health or mathematics. So there's an opportunity, because biochemistry is so broad in terms of what you can do at the end, to combine it with other things that you're passionate about. And I encourage people to do that. So you can tailor your degree, or you can choose some of these pathways. Now, if you were interested in, say, doing engineering but maybe wanted to do bioengineering ultimately, then you might want to do the double degree, which is involving engineering and biochemistry, so that's a possibility. You may be interested in environmental science. There's opportunities to do that as well. There's a lot of different places that you can go with any sort of science degree. So we teach you your core subject specific knowledge, but we also teach you a lot of what we call transferable skills. Things like critical thinking, critical analysis. There's an information-rich world out there. It's hard to know what to judge as being really good sources of information, and others that are not so good or potentially fake news. And we want our students, our graduates, to come out of there with a really good critical thinking skills, so they can go into situations and analyse what is accurate, why is this accurate, and challenge and think about things. So those are the sorts of skills you'll get. And problem solving. Science is all about problem solving. Biochemistry is about problem solving, and applying the knowledge that you learn to solve problems. And I think that those are things that we need in our graduates. We desperately world needs problem solvers, innovative thinkers, and so those sorts of skills are going to be useful anywhere. I would say typically a student who wants to go into biochemistry would have an interest in biology and an interest in chemistry. So they would probably come from school with some biochemistry, some biology and some chemistry background. They wouldn't have biochemistry specifically, but they'd have biology and chemistry. They may have in their biology course got really excited about the molecular level biology that they did, and they may also be interested in chemistry. That would be a good base to come through. However, I think you have to be passionate and determined and dedicated and excited about the subjects, and I've seen students come in with different backgrounds, and we do have some foundation courses that you could do if you came in with a background where you didn't have quite enough biology or didn't quite enough chemistry. So there are some things you can do to get yourself a bit more familiar before you take the main courses. And if you're really passionate and interested in the subject, but you think, I don't have all the background I need, then I think it's really good to come and talk to somebody and say, look, with my background, could I do this? And how would I go about doing it?